the user programming function allows the customer to create their own environments. The system comes standard with an anaerobic environment, which is 0% oxygen, and a microphilic environment, which is 6% oxygen. So these two you see right here come standard on every instrument. However, if you want to do maybe capnophilic environments, so you want to do high CO2 environments, you could add a second gas with 100% connection and put 100% CO2 on there, and then you could program certain recipes and add CO2 or change your CO2 level. So you can see here we have our standard 2 recipes. Somebody put one they call Capno in there. We have different environments here for CO2. So here's one with 100% CO2. Here's one with 52% CO2, 29%, 6%. So you see the programming function allows you to make those changes. Previous page, close. So if we wanted to create a new recipe, we would go back into there again, hit new recipe. We would name it. I'm not going to save another one in there. We have a lot of them in there. But then the first thing you would do is you always want to work from CO2 level with the Anoxomat. Again, the system is based on the Macintosh and Fields evacuation and replacement method, and that is based on removing oxygen from your environment. So you want to start there and say, how much oxygen do I want in the jar? And you see by sliding this, you see the O2 content moves there. So let's say we want 3% oxygen. And then our gas 2 you see here is 100% CO2. So let's say, whoop. All right, let's do this. Oh, I hit the wrong one. Close enough. There we go. So there's an environment. By using the 2 other slider bars, the 2 other gases, I can say, okay, I want 50% CO2, roughly 3% oxygen, and then the rest is filled with nitrogen and a little bit of hydrogen, which is part of the gas mixture. So we can adjust and create any type of environment we really want, depending on the gases that we have in the system. So I'm going to close out of this. And no, I don't want to save it. And then we're going to close out of that. So that's one of the features that is available on the system that I think is very useful for some organizations, particularly if you're looking to do the capnophilic carbon dioxide bacteria, because you're probably using a CO2 incubator right now, which uses a lot of CO2. And by using this, you can reduce the amount of CO2 and you can use a standard incubator. So instead of putting everything into a CO2 incubator, you just create the environment in the jars, and then you put those into a standard incubator and reduce the cost of the CO2 you're using in for every system. So the other thing I want to talk about is I showed you the printout. The printout has the ability, excuse me, I got to get in front here so I can type a little better. Okay, the other thing I wanted to show you today was the registration screen. Now on this screen, what this does is this offers the opportunity to add more information to your printout or to add more information to what is presented with every jar, or how to do tracking of your jars and tracking of your samples. So it allows you to basically what we call track and trace in the system. So the first thing you can do is you can set up a lab ID and a department ID. So as you can see here, we have the lab ID is Advanced Instruments, AI, and the department is Microbiology. Now, the next thing you can do is create jar setups or registered users. So I'll go to registered users first, and you can create users here and give it a name and a user code. Now, it's just a name and a user code. It's not password protected, really, as you say, but it allows you to know who ran that particular cycle if you want to. They would have to put in their user code to be able to run the cycle. So you can put as many of these as you want in there. Then there's the jar setup, and I think this is the more important thing for most people, is looking at the jar registration screen, because it allows you to put information on a printout, for instance, or to download to a data collection system about what's in the jar and the jars themselves. So you can put a jar ID in there. So if you say choose jar ID, and then you can choose to have it optional or required. So by choosing that, it means it's optional. If I click this one, it means it's required. You can have a reference, a sample ID, incubation time, incubation temperature, and a number of other items there. The other thing you can do is put multiple IDs, and then you can also set it up to pre-scan. So you could pre-scan all your IDs into the system before you started creating the jar. So I'm just going to put in a jar ID this time, and I'm going to save that, and then I'm going to run another cycle to show you how that works. But you have a lot of options there to, you know what, I'm going to go back there. I'm going to make them optional. I want to show you some of this. I'm not going to make those required, but I want to show you the printout with all the other information on it. Okay, that's good enough. Save changes. Close. Close. Now, there's a number of other things you see here in the setup menu. The data interface, that's a data interface, which allows you to take the data and from each of the runs and send it to to a computer. You have a catalyst test, that's for maintenance, and you can print a printer test. There are multiple languages. Machine stats, that would be for service people as well, and then advanced would be for anybody in the service department. So the only real thing that you're interested here would be your date and time and your registration screen is things that you might have to set up in the system. Okay, so now we're back to our main screen. So I'm going to choose a different tube now. I'm going to connect it to another jar. I'm going to hit microaerophilic again. I'm going to hit start, and you're going to see if I did it right. Well, it didn't do my jar ID. It said it's not connected. Okay, so this is a good example. Always good to have an error message when you start something up. So I connected this system to jar tube number 3, and it's saying that that's not connected. So something, either I didn't get it connected all the way, so I'm going to pop that loose. I'm going to start over, but this is what I'm talking about when we talk about the QC system, is that it will tell you before you put the jar in the incubator if there is an issue. Now, in this particular case, it said the jar wasn't connected. So I'll hit stop, and I want to go back into setup and see why it didn't ask me for my jar ID. Now it shows you that it's asking for a jar ID. So I'm just going to put in a jar ID, and it shows you the other things I chose here are reference and sample ID. I can choose to put things in there. And then I can hit start again, and it will skip over the ones that are optional. So now we're going to finish running our cycle. And we're going to, I'll show you the other printout. So the one thing I want to talk about here is the gas connections. And a lot of people ask the question, are there options for the gas connections? For the Anoxomat, you can use, like I said, the 85% nitrogen, 10% CO2, 5% hydrogen, or you can use 80% nitrogen, 10% CO2, and 10% hydrogen. It's just that we need at least 5% hydrogen for the Paladox catalyst to work properly, so you want to assure that you have that 5%. Some people will use 10 just to be safe, so because they know that sometimes the variations on the gas mixtures, but either one will work just fine. The other thing to point out is the system is fast, as I've talked about earlier. As you can see, this takes about 3 minutes for the microaerophilic cycle to finish up, which is very quick compared to any other system out there. The anaerobic cycle takes about 5 minutes to anaerobesis. So we have about a little over 3 minute cycle time that runs through the 3 evacuation and replacements. But then it takes another couple of minutes for the catalyst to completely remove that 0.16% oxygen that's still in the jar. So by having it so fast, we're assuring you that none of your bacteria are dying during the process of getting to anaerobiasis. We're assuring better recovery, faster growth, and larger colonies. Most importantly there is that you're assuring yourself that you're going to get growth because you're assured that you're getting the right environment in your jar every time you push the button on the system. As you can see by my couple of failures here, it always lets you know if you didn't do something right or if you didn't connect something correctly. So there's never any chance of putting a jar into the incubator and not knowing that you have the correct environment. This is critical for most clinical laboratories, obviously. If you have a failure of, say, a competitor's type product, you then have to go back to the patient, reculture the whatever you're culturing, and start all over again. We could pretty much eliminate that possibility because, again, we know up front that our system is going to tell you if there's any problem with the environment before you put it in the incubator. So we've completed our cycle, and I just want to show you this new printout, if you can see that. So you can see you still got the serial number, the date and the time, but you can see now here you have the jar ID, the reference sample ID. You can put in incubation time, date, temperature, and then if there was more things down here that you wanted to add, you could add those. And then finally, you could actually even have a signature on the bottom of the system. So that's the registration portion of the system. And one of the features that I think is important for many clinical labs today. So again, let me just quickly highlight a few of the things. Quality assurance system to assure that the jars has the right environment. Fast, repeatable. You know every time you push the button, you're going to get the same environment, which allows you to be confident that you're going to grow the anaerobes that you're looking for if they're in that culture. And finally, it's accurate. We always get the same environment.